Hello and welcome back, chemistry friends. It's me, Mr. Right, bringing you chemistry the right way, a helpful guide to help you along with your chemistry studies, either from the conceptual level all the way through to those early collegiate years. So in a previous video, I was talking about naming polyatomic ions, and I realized that there's still more of that to cover. And it is important that you understand that what we're trying to do is make sure you have a solid foundation. Naming things, nomenclature, is very, very important. It's the language that chemists speak to chemists, right? Atoms speak to atoms and form an entire subject called chemistry. And chemists speak to other chemists about that process with names and symbols and maths and all those types of things. And you've got to get your foundation really, really strong. If we were talking about learning a new language, we often talk about learning the irregular verbs is really, really important because they're the ones that are most commonly used. It's a little bit like this. Understand, because chemistry is an old science, a lot of the rules were once hard and fast, and then slowly but surely the edges have been sort of taken off of it. So there's always going to be exceptions. Frankly, it's why I love chemistry, because there is classically an exception to just about every rule. And so with that in mind, let's make sure we kind of bulk down and really know those fundamental pieces, okay? Then we can understand the exceptions to those rules. So first of all, we'll start off with polyatomic ions. So polyatomic means we've got many atoms grouped together to form effectively one cohesive unit. And then the ion part means that what we've got is this unit, and then it's got either a surplus or a deficit of electrons, kind of that outer electrical negative coating. So we'll start off with something kind of basic and see if we can warm up from there, okay? So polyatomic, one of the more common ones, and again, you got to kind of understand this, right? That when I draw what we call a sulfate group, it's an SO4. What we're talking about is a collection of 5 atoms that, by effectively random chance, have all bashed into each other at the correct angle, at the correct velocity, meaning the correct kinetic energy, in order for electron clouds to overlap and morph shape and destabilize and excite and de-excite, all that technical stuff. These 2 things, or these 5 things, have hit each other at just the right angle, and they've made this group. And the reason that they've made this group is because if it were unstable, it would just unform and all the bits would fly apart again. But it's not. It's like you get this one collision and then boop, it sticks together, right? Very, very stable, very long-lived. We find sulfates all over on planet Earth, in the rocks and the minerals of the Earth. There are other groups, right, like nitrate groups. Okay, that's where a nitrogen and an oxygen meet. It's tremendously difficult to happen, naturally occurring. One of the best ways we know of making like nitrate groups is through lightning strikes. It takes a lightning strike to get enough energy to get oxygen and nitrogen fusing in the air to form these. Anyway, once these groups, these polyatomic groups form, they do so, but they also have either a surplus or a deficit of electrical charge, and that's what makes them an ion. So first of all, let's group them together. So now they're operating as like a cohesive unit. And then the sulfate group has a -2 charge, which means it has a surplus of 2 extra electrons on the entire ion, or on the entire group. And the nitrate group is -1. Now that makes both of them anions. Cations are positive. Makes them both polyatomic, right, anions. But let's make sure we understand kind of where we're coming from with that. So at the heart of every atom, we've got protons and neutrons, right, inside that nucleus. But it's the protons that have got the charge. Effectively, what I'm going to do is I'm just going to add up all the protons that we have here. Atomic number of sulfur is 16, so that brings in 16. And then oxygen, atomic number 8, but there's 4 of them, multiplied by 4, okay? So 8 multiplied by 4 is going to be 32. 32 plus 16 is going to be 48. So there are overall, in the sulfate group, there are protons, there are 48 of them, 48p plus. So that means that to equal plus a number of electrons and equal -2, there needs to be a surplus. There needs to be 2 extra negatives, so there are 50 electrons. Okay? Now the nitrate group, and this is for every sulfate group in the universe. If it's not like this, it's not going to be a sulfate group. It could be a twist or a change on a sulfate group, but we wouldn't call it a sulfate group. We'd call it something like, I don't know, a metasulfate or a radical sulfate. There are all these different terms in chemistry, but we wouldn't call it directly a sulfate. Going over to the nitrogen. Nitrogen has 7 protons, right? Atomic number 7. And then oxygen, 8 times 3 is 24, plus 7 is 31p plus. And plus a number of enegs or electrons equals -1. So it's got to be an extra 1 electron, so 32 right there. So that's the basis of where we get these polyatomic ions from. But naming them, again, you got to remember, this always happens, right? Sulfates are always, nitrates are always. But what do the names mean? So let's just take a quick look and find out exactly what we've got going on there in terms of names. So, first thing we're going to do, if we take a look at our we're going to take a look at a group called a carbonate group. Carbonates are very common, and your body depends upon them in a great measure, in a great sense. Common in ocean water, especially, etc., etc. Carbonates form limestones. There's a whole myriad of uses for them. So we got a carbonate, right? So a carbonate, CO3. That's its formula. You just have to know these. These are the ones you just have to know, right? There's certain things you just have to remember in chemistry, and unfortunately these formulas are ones, but there's ways of helping us out, right? Then all bound together, operating as one cohesive unit, and then an overall charge of -2. Okay. Now how do we get the name carbonate? Well, effectively, there is no prefix here. There's no prefix. That's empty. That has meaning. But there is this suffix, and that's the 8. And as I said in the previous video, a suffix of 8 means the presence of oxygen. That's symbol O for oxygen. It doesn't tell you how many oxygens there are. It just tells you that there's oxygen. So that's the bit that you have to remember. So that's carbonate. That's it. Carbon with oxygen bound together in a stable, cohesive unit with an overall surplus of 2 electrons. Carbonate. Okay. But what about the others? There are a list of other prefixes and suffixes, and you need to know these. So, oops, got rid of that 8. I'll put that back up. Gonna have to. Prefixes. So, there are ones that have special meaning, like thio and bi. And then suffixes are, like we said, like an 8 or an ite. Okay? Now these have very, very particular meanings. So a prefix of thio means that what we have is we have an exchange. What we've got is we've got sulfur exchanged for oxygen. Bi means presence of hydrogen. It's the way that the Greek versus the Latin prefixes are used. When in chemistry we talk about 2, we talk about di. But if we talk about bi, that doesn't mean two. Not like bicycle means two wheels. In bi, we're talking about the presence of hydrogen. Again, I didn't make the rules. 8 means presence of oxygen. What does ite mean? Ite means oxygen less 1, or less 1 oxygen than 8. Okay? Technically, really, thio is you substitute a sulfur for an oxygen. You take an oxygen out, you put a sulfur in, that's a thio. Bi just means there's hydrogen involved. 8 means there's a certain number of oxygens. If I do it correctly, right? If I do that correctly, I'll put an N there. That's that little number there that tells us how many there are. This is ite is N minus 1. And then we have a blend of the two. Okay, prefixes and the suffixes. And there is a prefix. There is the prefix like di, as in dichromates, and that effectively means not sulfur, not hydrogen, not a particular thing. It literally normally means it's practically double. It's like everything times 2. Okay, with exceptions. Okay, a chromate ion, CR4, chromate ion, CrO4, dichromate, Cr2O7. It's almost exactly double. That's what that di means. That's chromate, that's dichromate. Again, you'd have to take a look at that chart that you get given, or it's in the back of your text, to exactly nail this down. These are the rough rules. But let's talk about when you get the pair of them. It all depends upon how much oxygen effectively you have. So if 8 is N numbers of oxygen, I can have N plus 1. And if that's the case, I take the suffix 8 and I take the prefix per, right? And then whatever's inside of there, right? So chlorate, ClO3, perchlorate, ClO4. Okay, so it's the N plus 1 rule. And then if the oxygen is N minus 1, we just have ite. So it's 8, ite. And then if we have N minus 2, then what I've got here is I take the ite form and I add a prefix and I become hypo. Okay. These blends, these special rules at the bottom here, right? These do not stand alone. You can have thioperchlorate, you can have hypo biphosphate, excuse me. You can blend everything together like that. Don't be concerned that this is just one rule at a time. These all can get blended together, a lot like grammar. So just be aware of what the meanings come to. So let's just do a few worked examples together, right? So we took a look at carbonate. And just going to do a little Star Wars referencing here. Empire Strikes Back, actually. But if this is carbonate, CO3, excuse me, at -2, Oftentimes, by the way, the oxidation state, the charge number, is going to stay the same throughout. Okay? If this is carbonate, Han Solo was frozen in carbonate. So what would the formula of carbonate be? It's the N, that's the 8 form, minus 1. Everything else that stays the same. The only problem is that ion doesn't exist. It's not stable in that form. It just resolves itself down to carbon dioxide. So, sorry Han Solo, you weren't frozen in any carbonate I know of. But how about this? We're going to use a slightly different one, right? How about bicarbonate? Bicarbonate of soda, baking soda. Well, if I go bicarbonate, it means I just add a hydrogen. So CO3 becomes HCO3. The only problem is, it means the presence of hydrogen ions. And hydrogen ions have a positive 1 form. So we need to add that positive 1 to that negative 2. Okay? That's the bi form. And we can do that with everything, right? We can do that with if I've got a sulfate, I mean, let's just test our knowledge, right? As our last one. If I have a sulfate, SO4, whole thing at negative 2, these are the common ones. It's just common, okay? Molecular weight 96 approximately. Just get to know these ones, get to know them. That's sulfate. What would thiobisulfite look like? Right? What would that look like? Well, let's not be alarmed. Let's do this. Thio, bi, sulf, prefix, ite. These are the classic things we throw together for students just to see if you just know about the mechanics. It's not relevant to whether or not this exists. It's relevant to whether or not you understand the rules of naming. Okay? So, thio. Well, that means I've traded an oxygen for a sulfur. So oxygen goes down by 1, sulfur goes up by 1. So now I'm at S2O3. Okay? Bi means I have a hydrogen ion. And sulfite means I have 1 less oxygen anyway than I did sulfate. What about the charge? Well, we remember that the bi brings a hydrogen ion, H plus 1 plus negative 2 is negative 1. And that's the way that we talk to each other. We talk about oxidation, we talk about reduction, that's going to come up. We talk about polyatomic ions, we talk about metals bonded to these things. You'll get the grips of it. Just stay with it, because it's chemistry and it's the best science that there is. So with that, give this video a like, thumbs up, go ahead and contact me. I'm more than happy to make more videos with suggestions, etc., etc. And yeah, see you next time. Bye.